Imagine peering into a nearby dwarf galaxy and stumbling upon a hidden giant that could one day transform our own Milky Way. It sounds like science fiction, but astronomers now believe there's a colossal black hole lurking inside the Large Magellanic Cloud (LMC), one of the Milky Way's satellite galaxies, quietly waiting to reshape our cosmic neighborhood. How could something so huge remain unnoticed for so long? And what does its eventual collision course with us really mean? By the end of this deep dive, you'll understand not only how researchers uncovered clues pointing to this hidden black hole, but also why it's such a big deal for science. You'll see how the future might hold a galactic collision that could jolt the Milky Way out of its spiral shape, reshuffle its stars, and merge two black holes into a cosmic behemoth. So let's journey into the heart of the LMC, explore the latest controversies, and reveal just how extraordinary our corner of the universe might become in the distant future. The Large Magellanic Cloud is a dwarf galaxy orbiting the Milky Way at roughly 160,000 light-years away. With the naked eye, it appears as a faint patch in the southern hemisphere's night sky. For centuries, astronomers considered it a relatively quiet satellite containing its share of stars, gas, and dust. However, the narrative changed drastically when researchers noticed an unusual cluster of high-speed stars traveling through our galaxy. These runaway stars, called hypervelocity stars, move so fast that ordinary gravitational pulls within the Milky Way can't fully account for their acceleration. Intrigued by these stellar speedsters, scientists sifted through data from the Gaia Space Telescope, which precisely maps star positions and motions. They discovered that at least 9 hypervelocity stars in the Milky Way appear to originate from the LMC. This was a huge surprise. Hypervelocity stars sometimes form when a pair of stars, a binary system, ventures too close to a massive black hole. One star gets consumed or captured, while the other is ejected at breakneck speed. That's exactly what seemed to be happening at the edge of the LMC. Astronomers analyzed these stars' trajectories and found a consistent story. Some colossal gravitational force must have kicked them out. Further calculations suggested a black hole about 600,000 times the mass of our Sun. That's not a tiny stellar black hole. Those are often below 100 solar masses, nor a mind-boggling supermassive black hole of millions or billions of solar masses like the one at the Milky Way center. Instead, it seems to fit right in the elusive middle category, often referred to as an intermediate mass black hole. Many scientists initially doubted the existence of such a black hole, arguing that alternative explanations could exist. For instance, maybe a cluster of smaller black holes working in tandem could eject stars at high speed. But so far, the simplest and most compelling explanation remains that a single mid-sized black hole is the culprit. This direct link, hypervelocity stars pointing back to one source, makes the LMC's hidden object one of the strongest candidates yet. Still, this finding has stirred up some debate in the astronomy community. Some experts wonder if the velocity measurements might be skewed by inaccuracies, or if the gravitational interactions between our galaxy and the LMC are more complicated than we understand. Recent papers have also speculated that the LMC might harbor more than one massive black hole. Although these alternatives haven't gained widespread acceptance, they highlight just how much remains unknown. One way or another, the presence of hypervelocity stars strongly hints at something massive and possibly quite dangerous in our cosmic backyard. In the grand scheme of cosmic exploration, why is this discovery so significant? Part of the answer lies in the fact that we already know plenty about the smallest and largest black holes. Stellar mass black holes form when massive stars collapse at the end of their lives. Supermassive black holes, on the other hand, lie at the centers of galaxies, spanning millions to billions of solar masses. Yet that middle territory, black holes tens or hundreds of thousands of solar masses, has been much harder to confirm. Astronomers have long suspected that such mid-sized black holes exist, but solid evidence has been rare. Now, the LMC's mysterious ejector of hypervelocity stars appears to slot neatly into that category, plugging a crucial gap in black hole research. If this black hole is indeed around 600,000 solar masses, it provides a unique laboratory for studying how black holes grow. We still don't fully understand whether black holes start small and slowly accumulate mass, jump in size through mergers, or follow more complex evolutionary paths. Pinpointing a mid-sized black hole in a relatively small galaxy gives scientists a chance to observe black hole growth in a more controlled environment than we see in chaotic giant galaxies. Understanding this hidden giant could reshape how we talk about galaxy formation, too. Dwarf galaxies like the LMC are often thought of as simpler, less active cosmic structures. If the LMC is home to a black hole that is hundreds of thousands of solar masses, that challenges some earlier assumptions. Are dwarf galaxies more dynamic than we realized? Could mid-sized black holes be more common than we thought, lurking in even tinier galaxies? Recent rumors suggest that more dwarf galaxies may also house medium-sized black holes, and that we've simply lacked the sensitivity to detect them. Beyond pure curiosity, there's a more practical aspect here. Black holes heavily influence their surroundings, from star formation rates to galactic shapes. A mid-sized black hole in the LMC might be gently steering how stars and gas evolve there. The next time you gaze at the faint glow of this dwarf galaxy, consider that it might be shaped by a hidden behemoth. That realization alone speaks volumes about the scale and variety of cosmic phenomena we have yet to fully comprehend. Spotting a massive black hole in the LMC is intriguing enough, but one of the most exciting revelations is that the LMC isn't just quietly circling the Milky Way forever. It's actually on a slow-motion crash course with us. According to current models, the gravitational dance between these two galaxies will culminate in a significant merger in roughly 2.4 billion years. While that time frame may sound staggeringly distant, in cosmic terms, it's just around the corner. During galaxy collisions, stars largely pass by each other without colliding head-on because there's so much empty space between them. But the gravitational interactions can reshape orbits, disrupt cosmic gas clouds, and trigger bursts of star formation. Imagine the LMC pulling in closer, bringing along its reservoir of gas and possibly that hidden black hole. As it merges, we might see wave after wave of brilliant new star clusters popping up like cosmic fireworks. Some of this star formation could drastically alter the appearance of the Milky Way, possibly starting to distort our orderly spiral arms. Then, of course, there's the question of what happens when two black holes come into close proximity. The Milky Way already has Sagittarius A*, often abbreviated as SGR A*, a supermassive black hole roughly 4 million times the mass of our Sun. If the LMC's black hole, weighing in at around 600,000 solar masses, plunges deep into the Milky Way center, the two giants could begin a breathtaking dance of their own. Over millions of years, they would orbit one another, losing energy through gravitational waves, eventually spiraling inward until they merge. The final collision of black holes would unleash an extraordinary amount of energy, potentially allowing astronomers billions of years from now to witness one of the cosmos's most dramatic events. No one can say with absolute certainty how the timeline will unfold, especially considering the complexities of orbital paths and the interplay of dark matter in both galaxies. However, most simulations suggest that the LMC's approach will have lasting consequences for the structure of the Milky Way. While Earth itself might remain safe from direct collisions, the night sky, if humanity is still around to witness it, would look very different, teeming with new clusters of stars and transforming our galaxy into something more elliptical. Even the black hole at the galactic center might become more active, consuming fresh material or merging with its new neighbor in a spectacular cosmic show. Mergers between galaxies are relatively common in the universe. Our Milky Way likely grew to its current size by swallowing smaller galaxies over billions of years. The collision with the LMC is just another chapter in that story, but it could be a pivotal one. Astronomers predict that one of the most striking outcomes may be a shift in the Milky Way's shape, turning it from a well-defined spiral into something more chaotic before it settles again into a new configuration. If you think of our galaxy as a calm, orderly disk, collisions effectively shake the entire structure like a massive cosmic blender. Some areas get enriched with new gas, triggering star formation. Other regions might be stripped of dust clouds. The presence of a mid-sized black hole adds another twist. Wherever it roams, it can stir up gravitational mayhem. This black hole could wander for eons through the outskirts of the Milky Way before it finally sinks toward the core, carrying along stars and dark matter from the LMC. One of the key transformations could be the injection of new star clusters throughout the Milky Way. The LMC is no slouch when it comes to star formation, thanks to its supply of gas and relative proximity to our galaxy. As the collision unfolds, these star-forming regions could spread out, fueling the birth of countless new suns. Over time, this may fill the Milky Way with brilliant nebulae and young stellar groups, forever changing the cosmic neighborhood we call home. None of this is an overnight phenomenon. The process occurs over tens of millions to billions of years. But it serves as a fascinating reminder that galaxies are not stagnant islands. Instead, they are dynamic, evolving structures that constantly reshape themselves. We're lucky to live during a time when we can piece together the broad strokes of these transformations, even if the biggest drama won't fully unfold for many generations. And it all starts with that hidden black hole in our dwarf neighbor, an unassuming monster that could play an outsized role in the Milky Way's destiny. To appreciate the LMC's black hole and its potential future with our galaxy, it helps to look at some of the universe's other black hole icons. At the top of the Milky Way's list is Sagittarius A*, our galaxy's central powerhouse. We've long suspected something massive lurked at the heart of the Milky Way because we observe nearby stars orbiting an invisible point at breakneck speeds. In 2022, the Event Horizon Telescope collaboration released the first direct image of Sagittarius A*, revealing the swirling plasma around its dark center. That image confirmed it has a mass of about 4 million suns. Truly enormous, but still modest compared to some black holes out there. One such heavyweight champion is the black hole in the galaxy Messier 87, commonly called M87, weighing in at around 6.5 billion solar masses. It was the first black hole ever directly imaged by the Event Horizon Telescope in 2019. The glowing ring of superheated material around its event horizon stunned the world and provided unprecedented evidence that black holes are very real, not just theoretical oddities. Then there's TUN 618, a quasar so luminous that it's visible across great stretches of the universe. It's believed to contain a black hole exceeding 40 billion solar masses, a true leviathan by any measure. This cosmic behemoth continually devours surrounding gas, creating gigantic jets of high-energy particles that blaze across intergalactic space. In doing so, it exemplifies how black holes don't stay the same size forever. They grow by feeding on anything that ventures too close or by merging with other black holes during galactic collisions. Studying these famous examples gives us a time-lapse of black hole evolution. If the LMC's mid-sized black hole eventually merges with Sagittarius A*, it could set off a chain reaction leading to a far larger black hole at the Milky Way's center, perhaps approaching the mass range of M87 over eons. Though that might require multiple collisions and continuous accretion of gas, it highlights the reality that galaxies and their black holes are never static. They transform, combine, and evolve, leaving cosmic footprints that astronomers decode millions or billions of years later. As enthralling as this discovery is, it also leaves us with countless questions. While the hypervelocity stars make a convincing case for a black hole in the LMC, skeptics remain. Some argue that the complex gravitational interaction between the Milky Way, the LMC, and the Small Magellanic Cloud, another dwarf galaxy companion, could generate unusual star velocities without needing a single massive black hole. Others point out that if the LMC truly has a black hole around 600,000 solar masses, we might detect more indirect signs, like specific emissions or distortions in the LMC's structure. Additionally, not all researchers are convinced the black hole is alone. Rumors suggest there could be multiple black holes in the LMC, some stellar mass, others bigger, that collectively sling stars out at high speeds. While current data leans toward the single black hole hypothesis, the debate isn't entirely settled. Ongoing observations from Gaia and upcoming missions like the Nancy Grace Roman Space Telescope could clarify star movements to an even greater precision, hopefully resolving some of these questions. Another aspect stirring up controversy is the exact timeline of the collision. Estimates of 2.4 billion years for the LMC's merger with the Milky Way hinge on our best modeling of gravitational interactions and dark matter distributions. Small deviations in measurement or differences in the true mass of the LMC might alter the schedule significantly. Some astronomers say the collision could happen sooner, while others think it might be delayed if the LMC's orbit is more elongated or if there's an unexpected influence from the mysterious halo of dark matter enveloping both galaxies. On top of that, there's the bigger cosmic collision waiting in the wings. The Milky Way itself is set to collide with the Andromeda Galaxy in around 4.5 billion years. So, if the LMC merges first, we could see a chain reaction where the Milky Way has already undergone a massive restructuring before Andromeda arrives. That adds a layer of complexity to predictions. Will the LMC collision alter the Milky Way's path enough to affect its eventual fate with Andromeda? Might Andromeda also harbor hidden mid-sized black holes that come into play later? These intergalactic tangles remind us that we're all part of a grand cosmic ballet, one where every step is shaped by gravity's steady hand, and the final choreography is still being written. When you gaze at the night sky, it's easy to feel that everything above us is static and unchanging. Yet the story of the Large Magellanic Cloud's black hole and the hypervelocity stars it sends our way demonstrates the exact opposite. Our universe is alive with motion, drama, and spectacular events quietly unfolding across unimaginable distances and timescales. The revelation that a mid-sized black hole might be lurking in the LMC challenges long-held beliefs and opens a window into black hole growth that we've barely begun to explore. For now, the black hole sits safely outside our galaxy, but in billions of years, it may crash our cosmic party, merging with the Milky Way and shaking up the entire galactic landscape. Whether it merges directly with Sagittarius A*, or wanders through the Milky Way's outskirts before settling into the central region, it could set off a chain of processes that dramatically reshape our home galaxy. New stars may ignite in cosmic bursts, spiral arms may warp, and eventually, an even larger black hole could emerge at the center. Thanks for watching. Please like and subscribe if you enjoyed the video, and I'll see you on the next one.